grade 10 class, you actually have even seen this page. If you were to use your calculator to do 9 to the exponent of 1/2, you would get an answer of 3. How would you do that? You would push 9, your exponent button, bracket 1 divided by 2. You would get 3. If you did 27 to the 1/3, you would get 3. If you did 625 to the 1/4, you would get 5. Why is that? Well, does this make any kind of sense? 9 to the 1/2. That means, this is page 16, that means 9 multiplied by itself half a time. That makes no sense, right? This doesn't make any sense. But again, we could do the chart and explain why. This is what happens, though. 9 to the 1/2 equals 3. 3 squared equals 9. Now, what is the relationship between 1/2 and 2? They're reciprocals, right? Opposite means positive and negative, but they're flip over, right? Reciprocals of each other. So, if 3 squared equals 9, then what does that mean the square root of 9 is? 3. Now, if the square root of 9 is 3 and 9 to the 1/2 is 3, what do I know about 9 to the 1/2 and the square root of 9? They're the same. Now, you're all intelligent young people. Yes, you are, Ashton. Trust me. Even if I believe it, and I've only known you for 5 days, how can you not believe it? What is the exponent that we don't write but is always there? 1. What is the index number in this symbol that we don't write? 2. 1, 2, 1, 2. Everybody should remember this. 27 is, of course, the cubed root of 27 equals 3. So 27 to the 1/3 equals 3. So 27 to the 1/3 equals the cubed root of 27. Yeah, we already know this. So what does this tell us? That x to the a over b equals the b root of x to the a power. All of you took grade 10. If you took grade 10 with me, you've seen that to death. I trust that you saw it in your regular grade 10 class if you weren't with me. Now, here is something that sometimes gets forgotten depending on your grade 10 teacher. This exponent, the numerator, can go in 2 spots. It can go right down here with the radicand, or this can be written with the a out here, the whole thing to that power. All of you at some point should have seen one of these. If you haven't, that's the trick. The denominator becomes the root, the numerator becomes the power, the base becomes the radicand. Everyone's cool, right? Now, we're going to start with this one here because it's a really difficult one. I like to start with a difficult one to make everybody see they know what they're doing, and we'll do a few easy ones, and we'll get back to some more difficult ones. What about this bothers you? The decimal, right? Decimals bug us because they're related to fractions, and fractions scare us all, right? Fractions are scarier than what's a scary movie that's been out recently? Don't say it. Us. I haven't seen Us yet. Was it scary? Don't spoil it. Okay. Then I won't bother. This bothers us, though. But this is really just 4 100ths, isn't it? Right? Okay. To the 3 halves. Well, what does that denominator become? It becomes the root. So I need the square root of what? 4 over 100. And what am I going to do with that whole answer? Put it to the third power. Well, what's the square root of 4/100ths? 2/10 to the third power. And what do we know about that 3 when there's a fraction as a base? Where does that 3 go? To both. So that's 2 cubed over 10 cubed, which is 8 over 1,000. Ease, peas, lemon squeezy, right? But that one question actually has math from grade 3, 4, 9, and 10, right? And even a bit of 11. Everyone cool? That was the difficult one. Here's an easier one. How are we going to rewrite this, which is in exponent form? How am I going to put that in radical form, which is then something I can simplify? What will happen to the 3? It becomes the root. What will happen to the base? It becomes the radicand, yes? And that whole thing goes to what power? 4. We don't need a calculator to the cube root of 27. What is it? 3 to the 4th power. We don't need a calculator to do 3 to the 4th power. What's 3 times 3? What's 3 times 3? No. 3 times 3. 3 times 3. 9 times 9. 81. Smart kid, see? It's okay. What scares us about C?
You have to raise a fraction exponent.
Right. If I gave you this, x squared cubed, what would you do? Add? You'd multiply. So what are we going to do here? What's 1/3 times 2? 8 to the 2/3. And now all of a sudden we can do this in our head, can't we? Where does the 3 go? Where does the 8 go? Radicand. Where does the 2 go? The power. We know in our head what the cube root of 8 is. What is it? 2. We know what 2 squared is. What is it? 4. Now, obviously, ladies and gentlemen, will we always know this in our heads? Will we always know the root that we're dealing with? No. Let's say you forget how to simplify this when you don't know it automatically. Notice, please, I got a whole unit on radicals to review that with you coming up. Okay? All right. So, D is exactly the same as A. So how shall we solve it? Why is 0.49 a pain? Because it's a decimal. So let's make it into something we can deal with. What is it? Right. All of that to what power? Now tidy it up. Where does the 2 go? Root of what? 49 over 100 to what power? 1. Do we even need to write 1? No. Of course not. What's the square root of 49 over 100? 7 over 10. Easy peasy lemon squeezy. What's different about E? The exponent is a decimal, which makes it a mixed number. What is it?
It's like 3 over 2.
3 over 2. And now we can do it in our heads, right? Where does the 2 go? Where does the 16 go? Radicand. And where does the 3 go? Outside. What is the square root of 16? 4. What's 4 cubed? 64. You guys do F. When you think you have an answer, cluck like a chicken. I'm just kidding. Don't really cluck like a chicken. But sometimes I say that, and I don't say I'm kidding, don't cluck like a chicken, and kids actually start clucking like chickens. It's clucking annoying. Thank you. Thank you. Okay. What should your first step have been? 81 to the 3/4. Then what? Fourth root of 81 cubed. Mr. Myers, I can't do that on my... Yeah, you can. We just did it right here. 3 to the 4th is 81. So what's the fourth root of 81? 3 cubed, which is 27. Now let's talk about what happens when it doesn't work. Well, which one? F? No. 3 times 3 is... Look. You cool now? Okay. All right, let's look at this. When you look at this right away, you say to yourself, self, that is the 5th root of 8 squared, yes? Right? Everyone agrees, yeah? Does 8 have a 5th root? No. It can't have a root bigger than a 3rd root, right? So this is where this comes into play. This rule. That A can go right under there. So this 2 could go under here. And this could be the 5th root of 8 squared. What is 8 squared? Yes, Stephen. 64. Now that does get simpler because that, Stephen, 2 to the 6th, right? Let's pretend that you remember grade 10 and you were able to do this in your head. How many groups of 5 can I get out of there? And if you don't remember this again, don't worry, we're doing a whole unit on radicals. How many groups of 5 could I get out of there? Just 1, right? So I can bring out a 2. And how many 2's did I leave under there? 1. And that is your math class answer. What if we're in physics? In physics, would you leave that as an answer? He moved 2 times the 5th root of the square root, 2 times the 5th root of 2 centimeters. Would you say that? So then we would use our calculator to simplify if we were anywhere but math class. In math class, we want to simplify it this way. And I'm going to remind you how to do it in the next unit. I just wanted you to see that this is the same as if the 2 was out there. Is everybody okay? All right. Now this one is really barfy, yes? What would I do with this one to put it into radical form? What would it look like? 7th root of what? 0.6 to the 15th, yes? Because I'm going to bring the 5 in there, yeah? Or the 15 in there. How many groups of 7 can I get out of 15? 2. So I'd have 0.6 squared, then the 7th root of what? How many 0.6's did I leave under there? 1.6. And that would be done. Math class answer. Everywhere else, we'd use a calculator. Is everybody cool? Again, if you are just like, oh, yeah, it's okay. Because in 3 days, we're going to completely review this, and then we're going to add new stuff to radicals. Everybody cool? All right. I'm done. You're not going to do any of that. That's junk. This page is where we are working now. Please notice no calculators. Let's do it. We are on page 23. No, I lie. We are on page 17, halfway down. What's this? What do you notice about point 3 and point 3? Same base. What do I do with the exponents? Add them up. 0.3 to what power? 2. Now I say simplify without a calculator. Is that simplified? No, so what is it? 0.9? You're close. What is it? 0.09. Why? That's correct. Isn't that 3 over 10? And then that's squared, yes? Well, what's 3 squared? What's 10 squared? 100. 900th is 0.09. Yeah? All right. How many of you are scared by number 2? Be honest. A bunch of you are. Why? It looks gross, doesn't it? But what do you see there and there? Same base. So isn't this just x to the negative 4 squared and x squared cubed? So what's this? X to the negative 8. And what's this? And then what would you do? So what's negative 8 plus 6? X to the negative 2. Now, what does a negative exponent do to its base? Reciprocates it. Well, isn't this base negative 3 halves to the negative 2? What does that negative 2 do to this base? And some of you are going to make a mistake here. It flips it, so I now have 2/3 to the positive 2. Is that right? What did I do wrong that most of you probably were going to do wrong the first time? You're going to forget that this negative, because flipping the fraction only changes the exponent. Now, what is this squared? Negative 4 over 9? Negative squared. You have the right numbers. A negative number squared. 4/9. Yeah? Yeah. Here, what am I going to do? In this one, I only care about the exponent laws.
You add the top part and then subtract it.
So what's the answer? You should be able to do that in your head, right? What is it? 1.4 to the power of 9. Why is it 9?
Because the minus.
Right. 7 minus 2 is 9. Yeah?
Wasn't the 1 times 4... Wait. 1.4 times 1.4 count for negative?
No. Because they're all the same base, right, Yulia? This would be the same as x, x, and x. Add them, x to the 7th. And 7 minus 2 is 9. What about that one? Should it scare you? Does it? Of course it does. Are they all the same base? Okay. So what do I need to do in the new denominator there? Add them to get what? Six thirds, which is just 2. But you don't want to change it to 2. Why? Because I've got a fraction to deal with. Isn't that 7 to the 2 minus 6 thirds. What's 2 minus 6? 7 to the negative 4 thirds. What bothers us there? What does a negative exponent do to its base? Flips it. So what does it become? 1/7 to what power? The 4 thirds. What is 1 to whatever power you have? 1 over 7 to the 4 thirds. Now, can I leave it there? I can, but I need to be aware that I might have to do future math. So what's another way I could write that? Nothing new, right? Nothing new, just bringing all the math you've ever used to one question, right? Everybody cool? Five. You should be able to do that in our heads. What do we get? X to the 5th and y to the negative 2. What's got to move? The y. What about here? How should I look at that? Should I look at that as 10a to the 5th b to the 3rd divided by 5a to the 3rd b to the negative 2? Or should I look at it as 10 over 5 a to the 5 over a to the 3 and b to the 3 over b to the negative 2? Which one's easier to deal with, the colors or the whole thing? The colors. What's the first one? 2. What's the second one? A squared. What's the third one? B to the 5. So what's the final answer? 2a squared b to the 5th. What's happening in 7? So I got 1.5 to the what? 15 over 1.5 to the 5. Then what do I got? Could I go further? I could. I could do a lot of stuff with this. Is this okay? Is it? Is 1.5 3 over 2?
Yes.
Okay. Is this okay? 3 to the 10th over 2 to the 10th. Is that okay? Is actually evaluating this crazy big number okay? Hitting 3 exponent 10. That's a big old number, right? I can't do that in my head. 2 to the 10th is 64 is 6. 128 is 7. 256 is 8. 512 is 9. 1024. It's something over 1024, but I can't do that in my head. 3 to the 4th is 81. 3 to the 5th is 405. 3 to the 6th is 1215. 3 to the 7th is 3,615. 3 to the 8th. Oh, God, no, I can't even be bothered. So if I can't be bothered, do I expect you to do it? Of course not. We're grown-ups. What's weird about 8? Because there's 2 ways to look at it. How would you look at it, Jacob? Jacob says he would do the cubed root of 8a3b6, all to the first power. Does he need to care about the brackets in the first power? No. So he would take the cube root of 8, which is what? 2. What's the cube root of a cubed? What's the cube root of b to the 6th? B squared, and be done. What if you didn't see that? What's your other option? 8 to the 1/3, a to the 3 times 1/3, and b to the 6 times 1/3. 8, you know that's 2. 3 times 1/3, you know is 1. 6 times 1/3, you know is 2. Do I care how you do it? Will I ever care how you do it? Will I care if you mess up the order? In this question, not so much. But this is really a 1 or 2 step question, right? What do you think is going to happen when it looks like... Oops, wrong one. When it looks like... that. Is order going to become important? Yeah. What about this one? You going to leave it whole? You're going to split it up? You're going to split it up. What's 4 divided by 2? What do I do with those A's? What's -2 take away 2? -4. And what's 2/3 take away 1/3? 1/3. What there bothers us? The -4. Where does it have to go? Can I leave it like that? I can. But I might need to go further, so I better recognize that's also cube root of b over a to the 4th, right? Because these two are interchangeable. Whatever you need to do in math, you can change the way something looks as long as you keep the rules alive. What would you do here, Jacob? I hope you do the same thing as you would do in 8. Would you take the square root of everything there? Okay, well, some of that should bother you under there. What bothers you? I see a negative exponent, and don't I see 100 over 25? What's that? What's 100 divided by 25? 4. A over a to the 5th means there's a to the 4th down there. And where should that b to the 1/2 go? Right? Everyone cool with that? Does 4 have a square root? What is it? Does a to the 4th have a square root? A squared. Here's the problem, right? We've dealt with the 4. We've dealt with the a to the 4th. This is a problem, yes? Why? How do you get the square root of 1/2? What are you supposed to do there? This is where knowing this helps you out. Because isn't the square root of b to the 1/2 the same as b to the 1/2 to the 1/2? Isn't it? Well, then what do I do there? So what is that? What's 1/2 times 1/2? Say it loud and proud, kid who doesn't think he's very intelligent.
1 over 4.
B to the 1/4. And then I could rewrite that as 2 to the 4th root of b over a squared. We are not going to do 13 and 14. You all are going to attempt 11 and 12 right now. Hint, do not do what you think you should do first. You guys do 11 and 12. Tell me what the answer is. When you are done with that, listen, please. You are going to do page 20 and 21. Now, do you have to do all of it? Do you think? Some of you have been in my class before. Do you think you have to do all of 21, 20 and 21? It's practice? No, you don't have to do all of it. But let's say you do 2/3 of it. I show you the right answers tomorrow, and you get a bunch of them wrong. What should you do? Go back and correct them, and then try the ones you didn't do. Does everyone understand? Okay? It is 1:54. I would like to show you these two at around 2:05. Okay? So you got 9 minutes, 11 minutes without me talking. Then I'm going to show you 11 and 12. Then you're going to go back to work on 20 and 21. Yeah? Okay, go. I'm going to pause. No, not yet. How many of you did the grade 5 thing and brought that 2 there, and that 3 there, and that 3 there? Some of you will have done that. That meant you had to do a lot of extra work. How many of you simplified first? That's why the instruction is simplify. What do you get to do with that x and that x? Add the exponents. What's 3/2 and 1/2? 4/2, which is x squared, right? What is 2 and -1? 1. Now, -2 goes in for x. -2 squared. 3 goes in for y times 3. What's -2 squared? What's 4 times 3? 12. And you get it right away in your head. Simplify first every chance you get. Right? Now let's look at this one, because this one's snaky. This one is so barferific, I don't even like talking about it. How can we simplify this? Where would you start, Ashton?
Alright, so what I did, I brought in that 4 into that negative x.
You brought that 4 right there.
Yeah.
So you have x to the 4th. And then, now this is where something weird's going to happen. Is this negative part of the base? No. So it's negative x to the 12th, right? That it's not bracketed. Everybody cool? Because that's negative x cubed. So whatever x is cubed, then it's going to end up negative, right? And then all of that is cubed, right? Okay. So now what would you do with that 3? Bring it in to get x to the 12th and negative x to the what? 36th. Everybody cool? Okay. Now, this negative is causing me trouble now, right? Why? Because it's changing the base, isn't it? Okay. So, I can't put these together technically, can I?
And then you can multiply everything by -1.
But,
Yeah.
we're going to stop here for a sec. If I multiply everything by -1, what happens?
Oh, wait a minute.
Then this guy will be negative, right?
I don't know how I did it first.
I just ignored the negative and just did it.
One sec. This is a negative value, right? Because that negative isn't part of the base. This is a positive value, right? So inside these brackets, I have a negative value, don't I? And that negative value is going to be cubed, right? So it's going to be a cubed negative. Negative times a negative times a negative is going to be what? Negative. So if I know what I'm doing, I know my final answer has to be negative. So I can get to here.
Or wait, doesn't that 4 cancel out with the negative x3?
Does the 4 cancel out the negative x3?
Wait, I'm not good.
Why is this difficult?
I'm just tired.
Why is this difficult, though? Because we're all trying to follow the rules, aren't we? We're not talking about what's actually happening, are we? What does just this part mean?
What's inside the bracket times itself.
Negative x cubed, and there's 4 of them, yes? Why are you hitting them?
You figured out the Da Vinci Code.
Right? That's what's really happening, yeah? Everyone agree? What's negative times a negative? Times a negative? Times a times a negative? So this is really x to the 12th, isn't it?
I just saw the negative.
If you know, this is what I mean by knowing what's going on and trying to apply the rules. Is everybody cool? Because as soon as you write it all out, oh, negative, 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 negative. Right? So now I've got x to the 12th, x to the 4th, which is x to the 16th, right?
Yeah, that is
All cubed is
like
x to the 48. And x is negative 2. 48 is even. So my answer is going to be a gigantic what? Number that is positive or negative? Positive. Everybody good? All right. Now, you are doing 20 and 21. You will see the right answers tomorrow. You will notice, if you notice a pattern, are you allowed to start working in your head? Of course you are. So, like in my notes, after I show you x squared times x cubed equals x to the 5th, and I give you x to the 7th times x to the 9th, are you allowed to just write x to the 16th? Once you see the pattern? Yeah. If the pattern isn't there, then you got to do work. And then maybe you discover a new pattern. Okay? Everybody cool? Go.